Hello.
Hey.
I like to dance while that music's on, like to get myself hyped up, and I just like dancing. And I was so into it just now that I almost like missed the go live. It's like, oh shoot, there's 5 seconds, like game
Oh,
face.
it's me on the screen.
Oh
Stop
crap.
dancing.
Hello. I'm so excited for this week's You Choose.
Yeah,
I'm,
it's going
I'm
to
ex-
be great. Probably.
yeah,
Likely.
probably.
We'll see.
I'm
It's
excited
you.
for every week's You Choose, regardless of whether it's good. I can't know that. I'm excited at the possibility that it might be good. And we'll do the best we can. So I guess we're gonna start like we always start by recapping last week's You Choose. We're in the middle of an observability season, and last week we talked about metrics. What
Yes.
tools did we discuss?
So with CNCF, it's easy. The tools are Prometheus, and then Prometheus with something on top of it, and then the third choice was Prometheus as well. So it's basically variations of Prometheus.
Variations of Prometheus. So let's talk about Prometheus. One thing that was hard for me when I was first getting started, which was earlier this year, not that long ago, was like when you say Prometheus, you mean so many different things. You mean
Yeah,
generating,
you mean
collecting, maybe.
I thought that you would say you mean the character from Greek mythology.
Oh yeah, that part's confusing too.
No? Okay.
The idea
You
that
cannot
these are
Google it
characters
just by saying
from
Prometheus, by the way.
or Thanos. Yeah, Thanos can be hard to find. Yeah, the Greek character part has lost all meaning. I'll always think of Prometheus metrics now when I hear the word Prometheus. But anyway, the idea is it's a lot of things. It's not just metrics. It's generating metrics, collecting metrics, maybe transforming the metrics, ingesting the metrics, which I think just means putting them into storage. So storing the metrics.
Yep.
And then doing something with the metrics, which is querying / visualization or alerting.
Alerting, exactly. Now
Alerting.
visualization is...
Yeah, that's fair. Making it available
okay.
for some real tool to visualize.
Yeah,
the
you can do
metrics,
it,
yes.
but then you need a psychologist.
Wait, just because you
To
drive
visualize
yourself-
metrics directly in Prometheus.
Okay.
I mean,
I didn't know you could
it's
do
not
it at
really-
all. You're
yeah, you can. You type
Okay.
the query and then something pops up. And then you get confused and you go to Grafana.
perfect. Tried and true methodology. But there are problems with Prometheus, which is why we have Thanos and Cortex. So before we talk about Thanos and Cortex, let's talk about all the problems with Prometheus. Well, let's just say Prometheus is designed to run as a standalone instance, right?
Let me correct you. As a standalone,
Please.
unscalable instance.
A standalone. So that's problem number one. It doesn't scale.
Yeah.
Problem number two, you want to query stuff, but you can't query across instances because it's not
Yeah,
meant
because
to
you
scale.
cannot have... Exactly, because it's not scaling. Yes.
What's another problem? You
I
can't.
mean, just to be clear,
Uh-huh.
you cannot query across instances from Prometheus itself. Mm-hmm. What you can do is that if you use some visualization like Grafana, you can put multiple Prometheuses as data sources in Grafana and query.
Oh.
So
Another thing
you cannot query from Prometheus.
I didn't know about that Grafana way of doing it. You can also have a federated architecture where you have a central instance of Prometheus that scrapes all the I think they're called leaves, all the Promethei.
Yep.
Yeah, all the different Prometheus instances to try to do some of this stuff, but it's not really elegant and it's a lot of data to query and manage.
If there is something I learned last week, that's that plural of Prometheus is Promethei. That's probably the most important lesson.
All the Promethei. There's also there's also problems with long-term storage. Did folks teach you? Did you walk away convinced that long-term storage of metrics is worthwhile?
There are some cases, so I will admit that it's we learned that if you want to see what was it, like weather patterns from the past, and you're for some unknown reason collecting them in metrics, then yes, it's a good example. If you're, what was another example was if you're collecting metrics from cows that you're milking, maybe you want to see how your business is
Shout
going
out to
over time.
Clement.
Yeah. This is me. This is it's me. My personal demons that I don't see the point in vast majority of cases of saying, "Hey, I want to see my application is misbehaving. Let me go 1 year back in time and figure out why is that is happening." I mean, but that's me.
One case that I remember that I found compelling was this idea, like maybe there's a security breach and maybe it's been happening and you don't know how long and you want to understand what is the scope of data that was affected by the security breach, and having that old information can help you with that.
True, but you're most likely not going to find it through metrics, but through logs. Which happen not to be stored in Prometheus.
Okay.
I'm learning Prometheus. But yeah, there are reasons for long-term storage. It's just that they are not as common as people tend to say it is.
And really, our point here is Prometheus, regardless of whether you want it, Prometheus doesn't do it natively, and that's one of the things that these extra tools can do. And then the last thing that Prometheus doesn't do that we talked about is multi-tenancy. So you can now probably pretty easily guess what Thanos and Cortex do.
Everything that we mentioned, that we said that Prometheus is not doing.
Yes.
And if there is something that Prometheus is not doing, and neither Thanos or Cortex are doing it, then we're not going to even talk about it.
Then, yeah. Then we need a new project. That's a great idea. Let's start a new CNCF project. That's what the world needs. So Thanos, though, they do it, and they prioritize different things, and they do it in a different way. Thanos and Cortex now. So Thanos runs as a sidecar to Prometheus. And that sidecar does two things. It does, once the data in Prometheus gets old, by default, Prometheus keeps it for 15 days, I believe. But at some point, some configurable point, it takes old data and then it moves it over to object storage.
Yeah.
And then that sidecar also makes it so whatever data is in your Prometheus instance at that moment is queryable. Then it has, Thanos is a toolkit of components, so you only use the ones you need. So there's also components that goes in your object storage that makes your object storage queryable. So then you have this global query interface where you can query across instances, you can query short-term, you can query long-term. And then Thanos does a bunch of other things, but I think the big thing we talked about is that it's super powerful. Like it can do millions, I believe Saswata said billions of time series can be stored and queried. It says unlimited data storage. Of course, there's a cost with that, but I don't know that Thanos has an upper limit. It's more about the upper limit of your actual infrastructure than Thanos itself. Yes. So that's Thanos. And then what's different about Cortex? Do you know?
Same thing like Thanos, but without the UI.
That's true. No UI. But who really, I'm interested to know, like, who's really using the Thanos UI instead of using Grafana? Like, you're that deep in on observability that you're using Thanos, but you're not using but you're using the Thanos UI. Who is that person? Not very likely.
I don't think that UI will be missed. Maybe some kind of to see something is misbehaving. Let me see the configuration of it or something like that. But hey, I don't give much importance to UI in this case.
Yeah. So Cortex then is deployed differently. It's not a sidecar. It has its own standalone stuff that uses Prometheus under the hood. And then it's so it scales independently of your Prometheus. And then I think the big thing, though, is it does multi-tenancy. I don't think Thanos does multi-tenancy at all. So if you have a reason, like you have a noisy tenant, you need to add limits or like ingestion limits or query limits on any of your tenants. Or if you're like in some sort of regulated industry where you wouldn't want to share metrics. Metrics are just numbers, but I don't know, maybe there's some secret numbers that no one can know. Then that is your core reason to use Cortex.
Yeah, and that's also going back down to the UI, right? That tenancy, if you're actually using them through something else like Grafana, then multi-tenancy might be handled elsewhere.
And okay, then Grafana. And then the other thing with Cortex is it can receive metrics from other sources besides Prometheus, which maybe Thanos can do, but I'm not sure about. Definitely it's something Frederick talked about last week. Is so you can, if you're using, I don't know who's using other things for metrics, but if you're using like OTel collector or you're instrumenting with OTel for metrics, then Cortex can handle those. And I think that's it, right?
Yeah.
Is there anything you want to say to recap last week's episode?
Nothing.
Then it's time to reveal who won the vote and which one we'll see demoed today.
Yes. I have it somewhere. Wait, where did I put it? There's. I promise it's somewhere. Here we go. And the winner is
Ba-ba-da-da!
Thanos. So we should do the demo of Thanos, right?
That's how this works. Yes.
No, wait. I should remove the screen.
I can do that. Will you?
Yeah, there we go. Okay, cool.
All right.
Yeah. So, but we are not going to do the demo of Thanos.
No.
Now it comes the moment when you ask me why.
Yeah,
I can
why
give
not?
you. Do you want a polite or honest answer?
Oh, we all want the honest answer. That's why we watch you.
Honest. Okay. I haven't used it before, so first but that's not the reason. The reason is the documentation is absolutely bloody horrible.
Oh, snap.
Yeah.
Okay.
So look at this. Getting started. Okay. You can ask questions. Cool. Dependencies. Cool. We can get Thanos CLI, even though it's not mentioned what to use it for. Cool. We can build from a source code. Never gonna do it. Cool. We can contribute. Nice. There is a community about it, and okay, there is no on this page any way explained how you can install it in any formal way, but community might give you the answer. And there are 3 choices. Excellent. You can go to Prometheus operator. Cool. That links to the generic page and doesn't explain how to install Thanos. Cool. You can use JSONnet. Never. I'm not doing it. It's just too complicated. There are community Helm charts. Okay, that's very promising. There we go. There's a community. Actually, Helm charts. It's a group of Helm charts. Nobody understands which one. It must be the first one, right? Cool. And you say, where is it? Here. I can install by running Helm install. And then, what is the registry name? I don't know. What is the repository? I don't know that either. This command would not work. And so on and so forth.
Wait, it says, but right underneath it said to use the Bitnami.
Yeah, Bitnami what?
Bitnami, use registry Docker repository name Bitnami charts and then /Thanos.
Yeah, exactly. And then what are the values? How to do it? It's just horrible. I spent
Okay.
whole 15 minutes. Whole 15 minutes of my life trying to figure it out, and I couldn't, and that's my limit. So we're not gonna
Thanos.
do. I can give you the polite answer instead if you want.
Well, sure.
I have only one cluster. It doesn't make sense to run multi-cluster setup of it in a single cluster.
Right on.
So I'm forced to use. I'm going to use Prometheus. I'm going to set up Prometheus.
You're gonna...
That's the answer.
Okay? All
Okay?
right.
So
yes.
improve the documentation, boys and girls. It's horrible. There was even a comment in last week's session, something along the line, is it installable? I think that was our friend from Israel. Anyways, so I'm going to install, what am I going to install? I'm going to install, no, I already installed Prometheus because the logic is still the same, right? The base logic. And I have this Prometheus installed and I'm going to open it over here. Where is the, there we go. There's my Prometheus if it works. There we go, right? It's already collecting metrics. You can see, for example, and I just did a simple install, nothing really special. Kubernetes metrics are there, other metrics are there, everything is there, right? Now, Prometheus is cool in terms that, I mean, it collects metrics, it does everything needs to be done. You can query it from here. Very few people do. I mean, actually, it's very useful to query it for here when what you want to discover is not necessarily covered through your dashboards and what's not, and for whatever reason you don't want to query it from other place. But if you do, you can just install Grafana, which is not CNCF, but very, very commonly used together with Prometheus. There we go, Grafana.
And it's open source, yeah?
Where
Open
is
source?
it? It's open source, yeah, just not CNCF, right? Admin, and the password is from operator, right? There we go. That's the default one. There's Grafana. It's already connected. I connected it. Actually, when you install when you install both at the same time, it's connected automatically. Otherwise, you can put it in connections, I believe, right? In data sources, you can add whatever you want, among other things, Prometheus. And if you go to dashboards, and what should we look for? Let's say Kubernetes something. Let's say we want to look for Kubernetes pods. Now I don't see here. There we go, right? Networking pods, and you get, this might be too low of resolution. You get information about everything that is happening related to pods, right? Let me move it off the screen because I don't see it here. Let me change it to the production namespace. There we go. Those are the pods. That's what's happening to me in production. What I'm going to do is just to generate some traffic very quickly. Oh, I didn't install Hey. Just search Hey. This is a minor setback.
What's Hey do?
Hey is a very simple way to generate a lot of traffic to something, right? Think of it as performance testing. It's not a big tool. It's not serious, but more than enough for what we are going to do. There we go. Come on, come on, come on, come on, come on. It's going to happen, I promise. Actually, I don't, but most likely.
I have a joke.
Yeah. Oh, okay.
Where can you find a dog with no legs?
I don't know, where?
Right where you left it.
I regret that. I think that I asked you to tell a joke on one of the talks we did in a conference, and I regret that ever since.
You've created a monster.
Anyways, I'm going to run. So now for 5 minutes, I will be bombing my application with requests. And the reason why I'm doing all that is to, I'm going to reduce the time to 5 minutes. And you should see very soon a spike in network traffic, for example, or something like that. It will happen eventually because Prometheus is pulling metrics periodically. So once it starts getting the data, you will see spike.
Are these default queries, like default board settings, or did you set up these?
No, those come out of the box, and then you can
Okay.
create your own dashboards. What I personally like to do is use the dashboards that come out of the box and then start tweaking them or changing them to meet your specific needs. But there are quite a few that come out of the box, and they're kind of pretty good. I mean, good start point, right? Anyways. Eventually, it will show the metrics. We don't have to wait for that. You just need to trust me that all the metrics in all the different dashboards will be updated because I've started bombing my application with requests. And now we can go to the next one, whatever is the next subject.
Awesome. Thank you, Victor.
Awesome.
Now it's time to talk about tracing. We have some tracing experts with us backstage who are going to present soon. But before we bring them on...
I checked there's getting started guides. They're good. No worries, folks.
This isn't all for nothing. So we should give some context around tracing, period. First of all, what even is tracing?
Tracing. So if you go back in, and this is my interpretation, folks are going to correct me, right?
Please
A
do.
long time ago, we lived in a happier world where we had one application, maybe two, front end, back end, maybe a database, and that's it, right? And now we have tens or hundreds or thousands of microservices, and they're talking to each other, right? Request comes in, and then it goes to one of them, and one of them sends it here or there, depending on what's happening, and further and on 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 and you get the point, right? Anyways, requests are bouncing through services and applications until they're finally sent back to the users who requested something, right? Now, when things go wrong, or when they don't, doesn't matter, it's close to impossible to figure out, okay, what's going on, right? I know that the request entered my system, but then what happened with it, right? Why is it misbehaving? Because it could be in a 57th service down the line, right? And you have no decent way to follow what's going on. And then some clever folks thought, hey, how about we add some kind of identification to those requests and then start passing that identification to all the following requests that are issued from it. And if we do that, then we can trace it. We can find out, okay, so this is what's happening, right? Draw us a map of sorts with a bunch of information that we need of what's happening on the networking layer.
So a trace then is like an end-to-end transaction of what's happening. And each little
imagine
jump it
a
takes
child
someone...
drawing, you know when you had those mazes in daily papers, and then you need to kind of solve it to figure out where it went. That's what it is.
Do you know how I like to solve those mazes? By finding the dead ends and coloring them in up until the point until only the good way was left. Okay.
You don't
that's
need
a
traces
trace.
then. You just get fired.
I'm working backwards. Yeah. So a trace is end to end, and then a span is like a single jump is called a span, right? From one service to another is a span, and a series of spans make
does
up
not.
a trace.
Guests are going to correct me. Does not necessarily have to be from one service to another, right? You can have it within your application as well. Hey, now this is a span that it entered this function, and then it was processed by this function. So you have it.
So any subset of steps that happen within a trace is a span. Okay.
Yep.
That makes sense. And then here's a question. So my understanding is for metrics and for logs, you can do that at a service, like a infrastructure level. But once we get into traces, now we need to instrument our applications, which is a whole lot more work. Now we need to get developers involved. Is that true?
Yes, you need to instrument your application. Now, you can instrument your application many different ways, right? You can just say, hey, I'm running some sidecar container or something like that will capture input and output traces, probably. You can add, you can instrument your application in a generic way and say, hey, I'm not doing anything, I'm just instrumenting the application without me being involved. And then you get some lower level details. Or you can really pull up your sleeves and say, okay, I'm going to put spans into every function or wherever it means, right? So it can be on different levels, and depending on how much effort you want to put, right, it can be kind of almost automatic, or it can require few or many changes to your code.
And then the benefit of that is, you said you could find problems that you probably couldn't before, at least find them more easily. You could also find performance bottlenecks if one service is being super slow and slowing down the whole.
So
is there anything else?
Let's say that you say, hey, the response time of my system is above the threshold that is acceptable, right? Then you can first answer the question, okay, since there are 57 services involved in that single response, which one of them is the slow one, right? Which one is misbehaving?
Yeah.
And you can go deeper and say, okay, is this one, but which part of it, right? Kind of the fact that you tell me, hey, this application is slow does not mean much to me. If you tell me, hey, this function in this application is what actually is causing delays, that could be more useful.
Very valuable information. Here's another question.
Just to be clear, you will get information about the response time from metrics as well, but that will be very generic. That would be kind of, hey, your system responded in this amount of time.
And it's less about one call, right? It's more about a collection of calls. It's more, it has lots and lots of data points making up a metric, generally, is my understanding of that. But here's my question. So we had a
those were not questions so far. What were you doing so far?
I have another question. Put it on the list.
Okay.
OpenTelemetry and Prometheus. We did the open standards episode. And the thing I remember from that episode is the Prometheus friends, Richie, saying you need OpenTelemetry for traces, and OpenTelemetry friends saying you need to have a comprehensive metrics solution. You need Prometheus for metrics. So we've been talking about traces for a long time, and we haven't talked about OpenTelemetry. Why is OpenTelemetry itself so important for traces?
It's important to have a standard. Let's start with there and say, hey, the way how I do and stuff like that is not necessarily directly related with the tools or services I'm using, right? That makes you a bit more agnostic and able to switch or change. Now for metrics, it's a bit more and guests will correct me, right? For metrics, it's a bit more complicated because you might be using Prometheus and then it's not OpenTelemetry, or you might be using OpenTelemetry, or you might be using both. It's a bit kind of, I cannot with certainty say OpenTelemetry for metrics is all, kind of like nobody should use anything else. For traces, that seems to me to be easier to answer. Yeah, it's OpenTelemetry, right? It's standard. The tools are implementing it. Just use it, right? There is no good reason why you wouldn't. Well, in case of metrics, there could be a good reason because let's say you're using Prometheus.
So you use OpenTelemetry APIs to instrument your code with traces and SDKs to collect and modify those traces and give additional context, maybe. Cool. I think that's all the questions I have for you. We should bring on some experts.
I'm curious. They need to tell me how much, how wrong we were.
We need to add a new section of our show called corrections.
Yeah, each of you get 5 minutes and then another 5 minutes collectively to say everything we said that is wrong.
So we, please, I see some questions coming in chat already. That's wonderful. Please keep asking your questions. We have a question and answer part of the show, so we'll get to all those later. And for now, let's introduce our guests. So first we have Andrew. Andrew, welcome. Thanks for being here. Will you introduce yourself, please?
Yes, sure. My name is Andrew Redko. I'm software developer for all my life, and I've been Zipkin or contributor for many years as well.
Awesome. Thanks for being here and sharing your time with us. We'll see you shortly.
My pleasure.
And next up, we have Jonah. Jonah's representing Jaeger. Hello.
Hey there. How you doing?
Just fine.
Thanks for having me.
Yeah, thanks for being here. Will you tell us about yourself, please?
Sure. My name's Jonah Cowell. I typically work in product or CTO at various types of software companies, and I'm about to announce my new gig in the next couple weeks because I've been in between things. So
that's exciting. I can't wait to hear. Good for you.
Yeah, for sure. And I can't wait to hear about yours too, Whitney.
Yeah.
Does your project have anything to do with Meister?
No, but I do like Jägermeister, but that's irrelevant.
It could be relevant, but it isn't.
All right. We'll see you shortly for your presentation.
Thanks.
All right. Are you ready with the time, Victor? We're going to bring Andrew on to start very soon.
Yeah. Bring him in.
All right. Here we go, friend.
3, 2, 1, go.
Go. Okay. Thanks a lot. Sorry, guys. Thanks a lot for giving background about the tracing. It saves me a little bit of time. So Zipkin. What is Zipkin? Zipkin is a distributed tracing system. Distributed tracing system consists usually of 5 different parts, as I would say. First is instrumentation layer, collection layer, query layer, UI layer, and at the end, definitely the storage layer. Zipkin has it all. And because of the time limits, I'm just presenting a screenshot here But basically, what you have on the screen is a complete trace of the system taken in the context of Zipkin instrumentation. A little bit of history for Zipkin. Zipkin was created by Twitter in 2012. It's been 12 years old already. The core part of Zipkin is written entirely in Java, and it's designed after the famous Google Dapper paper, which is basically the foundation of all distributing systems, at least for time being. This is the first open source distributed tracing implementation available at that time, and basically others follow it shortly. Why you would like to use Zipkin and why you use Zipkin? So first of all, you would like to have your solution for storing traces across all your systems in one place and be completely in your responsibility area. You do manual instrumentation. For example, you just have to actually, as you guys discussed before, you just have someone from developer perspective, developer perspective, just go and instrument the code. And you also very likely have many programming languages and many frameworks in your software stack. And Zipkin has a bunch of languages support and framework support as well, as we're going to see very soon. This is why you can use it and why you should use it. Why to use Zipkin? So Zipkin is completely run by volunteers. It's not baked by any vendors. It's vendor neutral. There is no foundation behind it. It's completely under the Open Zipkin organization. Has a bunch of supported languages officially, as you can see on this list over there. The strongest part of Zipkin is instrumentations. We support so many of them. I can fill the screens out of it. A couple of examples on over there. So we support most of the most useful frameworks on JVM ecosystem, other ecosystems. For storing traces, we do have choices of Cassandra, Elasticsearch, OpenSearch, MySQL, and also some managed solutions from AWS, like managed Elasticsearch and GCP as well. Zipkin by itself supported by mostly every single tracing backend out there because the Zipkin format was very popular and gained a lot of popularity over the years. With that, why when you may not be using Zipkin? Sadly, we do have a couple of cases where we have to give up at the moment. First of all, on JVM, with the recent introduction of virtual threads, the code base of Zipkin is a bit old, and we do have issues with that. We do have issues with instrumenting applications which are heavily rely on virtual threads, which may be lifted by GK24. We're closely watching the space, and we'll update shortly. You need automatic instrumentation, some kind of runtime agent, basically just without any manual intervention will instrument your code. As of now, Zipkin does not have anything like that at the moment. The last point, you may look just beyond tracing and you would like to use a one-in-the-box solution for metrics and logs and even beyond them, profiles, everything. Zipkin at the moment is limited to traces only. And to finish up, there are a couple of more links to explore the Zipkin ecosystem. We have the core repository. We have very large contribution of additional instrumentation and integration layers available under Zipkin contrib page. And I guess with that, this is all my 5 minutes.
Great job. No
Thank you very
gong
much.
for Victor. Yeah, thank you for your time.
No gong.
No gong. Look how
Keep
disappointed
being
he
disappointed.
is. Thank you so much. We'll see you shortly for the question and answer part.
Thank you, guys.
Okay, are you ready for the time again?
Oh yeah, that thingy. Probably. Go for it. I'll figure it out. Yeah, 5 minutes. Go.
Go, Jonah.
All right, thanks. So I just want to start out talking about Jaeger. It's a little bit different than Zipkin. Jaeger was created by Uber and is a project that's part of the Cloud Native Computing Foundation. It was created around 2015 by some folks at Uber, and it was donated to the CNCF. It was one of the first graduated projects, so it's extremely mature. It is built on a lightweight microservices architecture, and it is written in Go. So it can deal with very high scale. That's why Uber built it, is to deal with the huge volumes of services and the transaction levels that they deal with. And so it's designed to run on Kubernetes natively. We have Helm charts, we have operators, and Victor, for you, we have a Docker container that actually generates tracing data and makes it super easy to get a little demo application up and running on your laptop with a single Docker command. And it supports multiple backends. So officially, we support Elasticsearch, OpenSearch, Cassandra, and we also natively support Kafka to be able to deal with really scalable, bursty workloads. And we have 25 other backends that are unofficially supported in that GitHub issue. We are working on some new things as well, which I'll highlight towards the end, unless I get gonged. And the UI allows you to really do deep diagnostics and comparative analysis of traces. The thing to remember is Jaeger was created on top of OpenTelemetry, which was one of the pieces merged into Open Tracing. Or sorry, other way around. Jaeger was built on Open Tracing and became a core part of OpenTelemetry. So it's native to OpenTelemetry. And we've made it even more native with Jaeger v2 that is just in its first release candidate and is going to be coming out soon. 2 of the 4 maintainers that work on Jaeger are maintainers of OpenTelemetry and creators of OpenTelemetry. So don't fast forward my slides. I'm going through here. Someone's changing my slides on me. Sorry.
It was me. By mistake. You get 10 seconds. No worries.
Okay, thank you. And it's kind of the default viewer for tracing in the ecosystem. So some users of Jaeger, some of the brands you recognize, pretty global brands. There's obviously a lot more, but these have been pretty public about using it. This is a view of a topology of an application. So it kind of shows you how the data is flowing. This is actually the demo application that you're going to get, Victor. And it kind of shows you the topology and the view of the application. And then, of course, you have the timeline views where you can search and find different traces and drill into specific traces and see exactly as the data flows. And just like Victor was mentioning before, you can actually see the SQL database calls. You can see the things that are happening internally. This is thanks to the way that OpenTelemetry works and the instrumentation works. Because we use OpenTelemetry, we have both auto instrumentation and manual instrumentation where the developer can implement it or anyone can implement it by passing a command in. And we have some pretty advanced ways of instrumenting compiled applications like Go. That's all part of OTel. You get that out of the box. There's kind of a little bit of a deeper view showing a SQL statement. You kind of get all this visibility by default when you use Jaeger. This shows you comparative analysis. So let's say you do a release, you can actually see, oh, look, there's a new service that popped up. I didn't know about that service. Maybe a different team built it. So it gives you some really nice views of what's happening in your application and also what's changing. I'm almost out of time, so I'm going to speed it up. This is kind of the overall architecture. Jaeger is a single binary, but it can serve multiple purposes. This is new with Jaeger 2. Before we had different binaries for different microservices. And there's a few different ways you can scale it out, and they're just kind of sample applications. I'm going to skip this one. We also incorporate Prometheus into Jaeger, so you actually get metrics about your applications, the red metrics, response time, error rate, and the latency. Or sorry, the response rate, the latency, and the errors. So you can see that inside Jaeger. We integrate natively with Prometheus. We built a whole bunch of new features over the last 12 months. The biggest one is Jaeger v2. And I know I'm going to get gonged. And this is the roadmap that we're working on, which is kind of some of the other pieces. I'm waiting for my gong.
I gave you 10 seconds extra.
You can come and participate and chat.
Wait. Oh, hey, stop. Taking full advantage, which I respect. Great job, both of you. Thank you so much. That was awesome.
Thanks.
So far, we just have one question in chat. But before we get to the chat, and I always have questions, let's do corrections corner. Is there anything you want to say about what Victor and I said? That did we have it get anything wrong? We said what a span is a subset of tracing data. What else did we say? I don't remember now.
I guess you were pretty right. Yeah. Sorry, Jonah.
Okay.
It all
Jonas?
seemed pretty accurate to me.
Yeah.
Okay.
I mean, there wasn't anything too off there. It's a good overview.
Excellent. Thank you. Next time, I think let's say something really wrong, Victor, and then see if our
To
guests.
test whether they're listening.
Yes.
Is that the goal? Okay, yeah, correct.
I mean, maybe the
paying
only one
attention.
thing is about instrumentation is that there was some discussion about like data collection and instrumentation. So the developer can instrument their code and emit both logs, metrics, and traces.
Mhm.
And you can get logs, metrics, and traces from infrastructure as well. The
Mhm.
data that you get in
Oh, yeah.
tracing is very valuable in the application and not so valuable in the infrastructure. Whereas logging and metrics, you kind of need both. You need metrics coming from the app, metrics coming from the infra, and same with logs. So
That's very helpful.
yeah.
And speaking of that application instrumentation, I think it seems like from your presentations, one big difference is that Jaeger has the instrumentation part is something that the Jaeger project isn't even concerned about anymore. That's an open telemetry problem, versus Zipkin is still owning the instrumentation and supporting different things. Will you each speak to the good and maybe the bad of that choice that each of you has made? Andrew, can we start with you?
Definitely. So Zipkin accumulated a lot of instrumentations over the years, and we have different frameworks which are not used as often anymore these days. You know, software is very changing landscape, but people actually do use them in many applications and many ecosystems. So we do support that. It definitely adds more overhead on supporting all those different frameworks and let's say you can call them legacy, I guess. Plus, UGDK versions also kind of we're trying to keep the baseline very minimal, so people actually can use our instrumentation in applications which are still using GDK 8 in most cases. That's kind of goal to basically be very very accessible, even in the modern software stacks.
That makes sense.
And legacy ones as well, yeah.
And Jonah, what about the choice to use only open telemetry for
So
instrumentation?
we used to have our own agents and our own libraries and instrumentation. We deprecated those about a year and a half ago as we moved as open telemetry matured. So Jaeger used to have its own instrumentation that was using the open tracing standard. And we moved to open telemetry because the open telemetry community's done so many more things that we haven't been able to do. Advanced ways of doing sampling, new language support, auto instrumentation. We didn't have half of the things that we have now at the instrumentation and data collection layer. And also, if you are using Zipkin instrumentation, Jaeger has always been able to ingest that. So both Jaeger and open telemetry can take Zipkin data. So if you instrument an application 5 years ago and you don't want to change it, you can actually just use that instrumentation today with any tool. So Zipkin's pretty widely supported.
Cool.
That's correct.
I also have the impression that within OpenTelemetry, now might not be that much, but in the past at least, tracing was always a bit ahead, right? That we got tracing became stable before metrics, and then metrics became stable before logs, right?
That's correct.
Yeah, so the challenge with OpenTelemetry, which you rightly pointed out, Victor, is that it creates an agnostic way to change the backends and the tools. So if you want to test out a new tool, you make a config change and it's easy. In the old days, you used to have to rip out all the instrumentation and agents, put new proprietary ones in every time you wanted to test something. And you can't instrument the same application twice usually. So it actually means like you're changing, potentially production systems. So OTel was designed to solve that problem for tracing. And that was the primary first goal of the project. And then secondary was metrics. And then finally logging was the last signal. And now soon you'll have profiling and you'll have all kinds of new signals coming as well.
Does Zipkin support OpenTelemetry tracing?
Yes,
Yeah.
we do
Okay.
support it as a Zipkin auto contributor model. Yeah.
And then it seems like one problem with tracing is that trace data there's a lot of it that gets generated really quickly. How do you each handle the problem of back pressure, of data getting generated faster than it can get ingested? Let's start with you this time, Jonah.
Oh, sure, no problem. So we have native Kafka support, which deals with that back pressure. So if your backend is getting overloaded, that is usually the way to deal with it. There's also a unique capability of Jaeger, which Uber built, that is in no other tracing system, which is dynamic head-based sampling. So that actually allows you to change the sample rate in production in real time. So it's a really cool feature. And Uber built that so that, let's say, when you start seeing latency or higher errors, you can actually ratchet up the instrumentation in terms of the sampling without overloading the system all the time. So the idea is not to collect data that you don't need, and yet when you need it, to reduce the sampling and start collecting more data. So it's a cool feature.
Yeah, so you define under what conditions you want to start collecting more data, and it does it for you.
Yeah, you basically change a config file, and then all of the agents collect that new config file, which changes their instrumentation. So it's kind of a cool feature that they use at Uber and built into Jaeger for that use case.
Awesome.
Yeah.
And how does Zipkin handle the back pressure problem?
So we do have basically two layers of that. First of all, application layer, where basically the Zipkin instrumentation it basically washes itself and tries not to consume as much memory as compared to application. I guess we have a limit of 10 or 20%, if I'm not mistaken. So if tracing is not able to keep up, we just drop traces, and when command metrics saying, okay, we have to drop them because we cannot keep up. That's the first one. So basically, application has to go, and tracing is secondary in this case. And we also have, I guess, some guardrails on collector layer as well. If we're not able to handle traces in collector layer as fast as possible, we'll also drop them. So tracing in this case seems to be not as essential as application itself. This is a good trade-off to have.
What when you're thinking about tracing, what's the limiting factor? What resource of all the resources that are getting used tends to go first? What do you have to concern yourself with the most?
Who goes first?
Yeah, Andrew, it's your turn. Yeah. Uh-huh.
Yeah. So I guess it highly depends on application. If you have application with very high requirements for throughput or latency, tracing may have an overhead. And to understand what kind of overhead you have, you basically have to measure and figure out, okay, can you trace every single request, or you have to use sampling strategies in order to sample by percentage, do some head-tail sampling if you can. In best case, you may rely just on collector layer just to help you out to actually catch the traces you're interested in. For example, use tail-based sampling. Actually, you trace post-factum and say, okay, this is really taking long. Why? And then you do this. It's difficult, but it's possible. But yeah, I would say it definitely adds overhead depending how engaging how involving your instrumentation. That would be the price to pay for it.
The storage overhead seems like
the storage plus as well the runtime overhead to actually collect all that and send it over. That's up.
Because that's, correct me if I'm wrong, that's basically the same answer we would get for any type of observability, right? Metrics should introduce also increase network communication.
Yeah.
If you ship too many logs because you're the person who enabled debug.
One of the examples people like Jonah presented, let's take example of SQL query. You would like to actually associate the span of executing the database statement with SQL. And SQL could be several pages long, right? Huge, specifically generated ones. You can have literally kilobytes of SQL sent over and over and over again. This overhead you have to accommodate somehow, and then you have ways to deal with that. But this is a price you have to pay basically to have a more absorbable application versus trading off details you would like to expose or store. That's a big problem.
So the only thing I would add is when you're using OpenTelemetry, you often have to create pretty big clusters of collectors, depending on what you're doing. So when you think about it, the filtering that you're doing, a lot of regular expressions and other things to try to reduce the volume of traces, that increases CPU. And as Andre was saying, tail-based sampling is very useful, but you have to keep a lot of the trace data in memory to make a sampling decision at the end of the trace. So the challenge there is that then memory becomes a problem. So it's either CPU or memory on the collector layer and then storage on the backend layer. But even on the backend, you can run into lots of issues. If you're running a lot of queries against the data or you're using it for different things, you can also cause other challenges on the backend side. So we get a lot of questions on our channel about scaling Elasticsearch or OpenSearch, upgrading backends, lots of different things around scalability of collectors are what we hear a lot from users about.
It seems to have so much to do with your sampling strategy.
Yes.
Yeah.
Yeah, and even is a little confusing for me because one trace is made up of a lot of little spans. It seems like if you lose some of those spans, you break the trace and then you don't have the end. So you have to consider. Do you have to consider each trace as a whole and then start to sample from there, or do you consider it from a span level?
So there's two types of sampling: head-based, where the decision is made at the beginning. The first trace that comes in, you make a decision like, oh, this is a health check URI. I'm going to just ignore it. So you make that at the beginning. Some you make at the end, like I want to only keep things that are over 1 second long for the whole trace. Then it waits for the trace to complete. It looks at the data and says, oh, is it more than 1 second? Then I'll keep it. Is it less? I'm going to throw it out. So those are the broad strategies, are either head or tail based.
And you're probably realistically doing some combination of both. Yeah. It's a question.
The problem,
I actually don't know.
The problem is if you try to mess up with spans, as you said, like remove some of them, add some of them, you're basically losing the truthful picture of your system, right?
Exactly.
How does this happen? Like the holistic trace is actually what you're looking for. If you cannot assemble it, it's better not to lie to users saying, okay, this is how it worked. No, it didn't work like that. You just drop some things out of it. And this is difficult, yes.
Yeah.
Sometimes.
Where if someone is trying to design a sampling strategy to help manage the amount of data that their tracing system is using, is there a resource for that? Where should they go?
I think this like OpenTelemetry. So basically, all the solutions do have some specific samples implementations, and you can plug your own. And they can go as simple as being probabilistic. Let's say pick value between 1 and 0 and say, okay, trace, not trace. To be very, very kind of complex, involving systems like Zookeeper to figure out, okay, which service already did trace, which one does not, where you are right now, should you continue trace or not? This is, I mean, I've seen many of them, and the sampling strategy is basically very related to framework you pick. Like Zipkin would be one. They look similar, but implementation may differ a little bit.
Can it happen that, I'm going to ask a silly question, but that the process that is making those decisions end up using more resources than
that you're saving?
You're saving.
Sky is the limit, right?
In Notel, it's pretty compact. Like when you look at the contrib directory and the processors, that gives you an idea of what you can do with processing traces. And that's where all the sampling and various other kinds of filtering are. And there's good docs in the OpenTelemetry website on sampling. But it can get really complicated, as Whitney was saying, when you start combining different strategies, the configs can get pretty ugly to deal with. So that's kind of always the challenge.
What's an example of a sampling strategy you've seen work well for some broad use case? Jonah, we'll start with you.
Probabilistic.
Oh, yeah.
So
probabilistic, yeah.
Yeah, I mean, the one that I think is the best is a combination where you discard things which are useless. So you would have a bunch of filters that say, health checks and various other things that you're using. And then I think tail-based sampling is the right approach, where you would say, I'm going to keep a certain percentage probabilistic of my 200 OKs. So I have a few transactions of things that are okay. And then I want to keep my 500s, or a percentage of those that's much higher. And maybe I want to keep things that have a higher degree of latency that I'm going to want to dig into. So it's sort of like a combination of those types of rules helps with getting a little bit of data when things are okay, but focusing on the things that you really want to dig into, you want to fix, you want to diagnose. But then when a customer comes in that's having an issue, you may not have the right trace data. So it gets a little tricky when those situations occur. So that's kind of the downside of the sampling.
How long do people tend to keep trace data? Is it a long-term storage situation like we were just talking about with metrics?
It depends on your use cases. Like in some organizations, they use it to understand usage of their applications and deeper types of data about it. But similar to logging, I mean, a week, 2 weeks is kind of minimum. And then it sort of has a diminishing law of returns once it gets older than that. But you can also summarize it. You could process it. Like at Uber, they run it through Spark jobs, and then they create summarized types of data that they use for analytics and lots of other use cases. So it kind of depends.
What's Spark jobs?
Oh, sorry. Spark is a machine learning framework where you can basically do big data number crunching. So if you wanted to create some type of aggregate or a customer view or something like that, you could do that. So it lets you use the data for, call it, more business purposes instead of technical purposes.
Interesting.
Yeah.
From a developer perspective, I would say that 1-2 days is probably the best time to keep traces on, because you have an alert, you have an issue, you have someone to look at it. It happened overnight. And if it didn't look on it in a couple of days, probably not very important, or it's not causing a problem. So people just keep it. Yeah, you definitely can keep it longer for different compliances or whatever you would like to associate with your system. But from a, let's say, live experience, 1 to 2 days would be probably the best time frame for traces to be available.
2 daes.
So Andre, what happens if you have to do a post-mortem from an incident that happened last week?
I mean, if I didn't work on it last week, I would probably look at it right before, right in the moment it happened, right? So I will definitely collect this data. If you ask me now, I didn't even participate in it, so I don't necessarily have to attach traces to that if it was not useful, right?
Is it common practice to sample even further in terms of what data stays super long term?
I don't know, to be honest.
Okay.
It probably may have sense for systems which manage, let's say, the solutions which basically offer out-of-the-box tracing system for as managed service. That probably could be useful for them. For if you're tracing the application you're actually being on call for, you probably will use them much often than you don't need to store stuff all the time, I guess.
Could also be for compliance is another use case where if you have a system that you want to keep that so that you can forensically go back a certain amount of time. Maybe a core banking system, a lot of trading systems, keep extra trace data just in case they need to go back and look at what happened, a few months ago when someone comes to them with an issue. They can then, kind of forensically recreate what the application was doing.
Fascinating. We have 2 questions from the audience. Do you have something to say, Victor?
No. I was about to say, let's go through the questions.
Oh, yeah. And then we're going to wrap it up. What about Grafana Tempo versus Jaeger?
So the guy that actually created Tempo is one of our maintainers of Jaeger. Tempo is a backend, so you can actually run Jaeger against Tempo. It doesn't have all the search capabilities, but Tempo is a backend like Elasticsearch or OpenSearch or Cassandra. So you can use Tempo with Jaeger, but Tempo does not have full text indexing. So you can't search for everything in the same way you can in the Jaeger UI. So it's a little bit limited, but it does work with Tempo.
Does Zipkin work with Tempo?
I don't know, to be honest.
That's fair. You can look it up in the documentation if someone wants
Yes,
to know.
I actually don't know. Yes, sorry about it.
Is there documentation on how to do post-processing using Flink/Spark?
So I'll start with Jaeger.
Yeah.
We actually have Flink and Spark jobs that are part of Jaeger that generate those call graphs and those views if you're not using in-memory data storage. And there's also actually a whole repository underneath the Jaeger tracing organization in GitHub that's like data science use cases that people have written that are pretty interesting, that process trace data with both Spark and Flink for various use cases. So there's a bunch of Jupyter notebooks and examples that people have contributed to the repository. So more like code that you can sift through. I wouldn't call it documentation, but there's been some work done and donated on that front.
Excellent. And what about for
Yeah.
Zipkin?
Zipkin is a very similar story. We do have the Spark drops for dependency, to construct the dependency graphs, all that. So that's aligned with the Jaeger, I guess.
Can this post-processing be done in real time?
It's a good question. So you need to understand that traces live in sync. It doesn't immediately start and end. So you can, but traces may just trace itself to be completed may take a long time. So that's a complexity of it. You can do.
Makes sense.
Yeah, you can try to be as close as possible, but you need to be careful to not have incomplete data available.
Yeah.
So the challenge with the real time is usually the back end can't run those types of wide queries in a reasonable amount of time. When we run in memory, we use a database called Badger, which does that in real time because the data set is much smaller. But when you go to an actual big data system, it's difficult. We actually have an intern working right now in Jaeger that's part of the Linux Foundation internship program that we run that is working on implementing real-time views with OpenSearch. So hopefully we might have something built this, in the next few months that does this for OpenSearch. But for the most part, once you get really big systems, you kind of need to do that post-processing to generate those high-level overviews.
This has been so informative and so fun. Before we say goodbye, I'm going to ask you each one last question, and that is, why should we vote for your technology? Andrew, why should we vote for Zipkin?
Zipkin is battle tested, proven to be solution for at least in JVM ecosystem. I can say for sure being very compatible with all backend systems and very very easy to use. We have a bunch of examples, a bunch of demos, a bunch of instrumentations available.
Amazing. Thank you so much for sharing your expertise with us. Goodbye. Jonah, why should we vote for Jaeger?
So we are part of the CNCF. We have a vibrant community. You can come and find us at KubeCon. I think that the contributions that we get, the ecosystem around Jaeger, and the fact that we're so aligned with open telemetry and the communities makes it a natural choice for people to go down that path. We hope to actually make it even more native to open telemetry in the future. So I think that it looks like a really good path for Jaeger to be the visualization and storage, and OTel to be the instrumentation. So that's why you should use Jaeger.
Thank you so much for sharing your time today. Goodbye.
Thanks.
Hello.
And it's only two of us left.
And we're back.
I love
to
how
two.
you kick people out before in the middle of
He said
bye.
goodbye, and I cut him off. It's terrible. I didn't get my chance to cut people off during the timekeeping today, so I got to flex my viciousness somehow. So please go to the CNCF's Slack workspace in the YouTube channel, you'll find a poll. Not quite yet. I have to go put it up. But in minutes from now, there will be a poll there for you to vote for either Zipkin or Jaeger. And whichever one wins, we implement into our ongoing demo. You'll see next week. So I think that's a wrap. Thanks so much, everyone. See you next week. We're going to talk about data collectors. It's going to be a spicy one, I think.
You think? Are we going to see the fight finally?
It might happen. Yeah. All right. Bye.
Oh, I should